Chapter 6, Section 4 is about applications of these linear systems that we've been talking about. We want you to be able to write a system of linear equations for a word problem, so that's what we're going to practice. But first, a quick reminder, this is when you want to use the three methods that we've been talking about between graphing, substitution, and elimination. Graphing is best used when you want a visual display of the equations or when you want to estimate. Okay, so if you just want to see what these equations look like, or maybe kind of rough estimate of what a solution might be, you would use graphing. Substitution is if one equation is already solved for one of the variables, so you already have an x by itself, or you already have a y by itself, or if it's easy to get that. That's when you would use substitution. And elimination is when the coefficients of one of the variables are the same or the opposites, or if it's not convenient to use the other two. Okay, so remember that when you're choosing how to solve your systems. All right, systems of equations are useful for modeling problems that have rates, mixtures, or break-even points. A break-even point for a business is when our income, or how much money you make, is equal to your expenses, how much money you have to spend. Okay, so if you notice these two lines, our income line is this blue line, the expense line is the red line, and right here in the middle is where they break even. They didn't actually make any money yet, but they haven't lost any money. They've made up everything that they had to spend. That's what we're looking for today when we're doing these application problems. Okay, so let's start with number 1. We're just looking for the break-even point. We're not looking for anything extra, just where are they equal. Okay, a fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each, and the designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay, for these break-even questions, we're always going to write two equations. The first one will always be about the expenses or the costs, how much they had to spend to make this happen. The second equation will always be about income, or how much money they are making when they sell these products. Okay, so we're going to look through our word problem and we're going to find any expenses. Those are these blue things, costs. Okay, so they had to spend $1,400 on advertising. That was a one-time cost, so we're putting that here. That's like our y-intercept. But then for every hat that they make, they have to pay $5.50 for the material. So that is like our slope. It's changing by $5.50 each time they make a hat. Okay, so our expense equation is y equals 550x plus 1,400. Now the income is how much money they're going to make when they sell these hats. So for every hat that they sell, they're going to make $12.50. So that's $12.50 per hat. There's nothing added on to that. It's only that. Okay, so to find their break-even point, being even is the same as being equal. So we're going to set these two equations equal to each other. All right, we're going to take, it's kind of like substitution. I know y is the same as 1250 times x. So I'm plugging that in and setting it equal to 550x plus 1,400. Okay, I now only have x's to solve for. So I'm going to solve my equation just like I normally would. So subtract $5.50 times x on both sides. Leaves me with 1,400 over here and 7x over here. And I divide by 7 and I find out that x is equal to 200 hats. So that means that once they sell 200 hats, they will no longer be in the hole any money. They won't owe any money, but they also will not yet have made a profit. But once they sell anything over 200, now they're making a profit. Okay, problem number 2 is about a puzzle expert who wrote a new Sudoku puzzle book. His initial costs are $8.64. Binding and packaging each book is 80 cents. Okay, so right there, those are our expenses. It's 80 cents per book, so that's kind of like our slope, plus the original 864 that it costs just to set this whole process up. Then they're going to sell the books for $2 each. So that is our income, $2 times however many books there are. and we're looking for a break even, so I know I have to set them equal to each other. So we have 80 cents times x plus 864 is equal to 2x. We're going to subtract this 80 cents times x. That leaves me with 864 equals $1.20 x. Divide by $1.20. And x is equal to 720 Sudoku books. That's when they will break even. Okay, so if they sell any more than that is when they'll start making a profit. Okay, last one for today. It's pretty short. A carpenter makes and sells rocking chairs. The material for each chair costs $22.50. The chairs sell for $75 each. If the carpenter spends $420 on advertising, how many chairs must she sell to break even? All right, so we're going to write our equations first. We have our expenses, and we have our income, and we know that we have to set those equal to each other. Our expenses, or what we spent our money on, what the costs were, is $22.50 was for each chair. So that's $22.50 times however many chairs we make. He also spent, so add on, $420 for advertising. His income is that he's going to sell these chairs for $75 each. All right, now I'm going to solve this for x. I'm going to subtract 2250x. So I have 420 is equal to 5250x. Divide by that 5250, so I get x by itself. And I find out that if I sell 8 chairs, we will break even. Anything above that will give me a profit. Okay, your homework for this is page 386, numbers 7 and 8, 13 through 16, and then the lesson quiz.